So let's take a look at example problem 2.5.1 from our text here. Problem involving two inputs and one output. For this problem here, they tell us to obtain the transfer functions x of s over s of s and x of s over g of s for the following equation. So they give us this equation here, 5x double dot plus 30x dot plus 40x is equal to 6 times f of t minus 20 times g of t. So, as we've done in all other problems, we're going to do our setup page. Now, I've had a couple students who have requested to submit their homeworks with Python or other types of word processing formats. So I wanted to go through and solve mine here doing this typed out rather than my hand solution. So the difference today that you've seen from the previous lectures is rather than me writing this out by hand, I'm going to be typing this out using just PowerPoint and equation editor. So just another option for you guys to do. This works well for me. I have messy handwriting, so sometimes it's easier to type things out, and then also it's easier to edit it in the future as well if you need to use it for a different homework or exam problem. You can reference back to it. So I'll be going through my hand solution today with my solution typed out rather than written out. So first page, same as we've done before, our setup page, we have our given. Our given here, I write out that given equation from our problem statement. Find, simplify down what is given in the problem statement in words into what they're actually looking for, and our variables here. So we have x of s over f of s and x of s over g of s here is what they're asking us to solve for. So again, this is still the same as all of our other setup problems. We can reference back to this quickly, understand, okay, here's my given information, and here's what they're asking me to solve for. So now that we have our setup page complete and we can reference back to that to understand what they've given us, what they're asking us to solve for, I now want to start my solution. So I write out my given equation here. And for my solution, I come up with a plan of attack. So one thing, an assumption that I've made from the problem statement here, is we're going to use the derivative property with zero initial conditions. So from that there, we can now write this equation out in the following form here. So we take that given equation there, write it out down here that we have 5s squared x of s plus 30s x of s plus 40x of s. This is equal to, on the right hand side of our equation, 6f of s minus 20 g of s, with those two functions there. So in order to get what they ask us to solve for, what we need to do is rearrange and solve this relationship shown here for our x of s. Recall we want those ratios that we've seen on the previous slide. If we reference back here, that we want to solve for x of s over f of s and x of s over g of s. So in order to do that, first thing we need to do is solve this equation for our x of s, or our numerator for these here. So I rearranged this just a little bit. I realized that throughout the left-hand side of this equation, there is an x of s that I can pull out front. So that's what I do down here. I make a little note down here. This is what I'm doing. I'm pulling my x of s out front. So side note for this here, as you're doing your homework problems and your exam problems, whether you're typing it out or writing it by hand, it's going to make it easier for me and the grader to follow along with your work if you put little notes as to what you're doing. This will also allow for more partial credit. So even if you miscarry something, pull out the wrong thing, drop a negative, most of your work is shown here. If you look at the grading rubric, a lot of it is just by the setup. You're getting a lot of points in the problem by going through and choosing the right key equations, choosing the right setup, doing the right methods, and the final answer is really only worth 2 out of the 10 points. So if we're able to follow through your work and understand that you know how to solve this, regardless if you dropped a negative sign along the way or miswrote a number, you're going to get most of the credit for the problem. So make this little side note here. I'm pulling out my x of s, plug this out up front, ends up with x of s times 5s squared plus 30s plus 40 is equal to the right hand side of my equation over here, 6f of s minus 20 g of s. So now that I have this here, again, I make a little note to what I'm going to do next to simplify and reduce this. I'm going to divide both sides by this denominator here, 50s squared plus 30s plus 40. So I divide this right here, put this as the denominator there. Those end up canceling out. Divide by the right hand side of the equation now. I have my 5s squared plus 30s plus 40 on the denominator here. So then I can reduce and simplify this down a little bit further once those two cancel out, and I'm left with just my x of s on the left hand side of the equation. It's exactly what I wanted to do here. So I do this here. X of s is now equal to 6 times f of s minus 20g of s, all divided by the denominator there, 5s squared plus 30s plus 40. So now looking at this equation here, we want to stop and think for a second. What are they actually asking us to solve for? So this is where it's great to be able to reference back to that first page. Okay, I need x of s over f of s and x of s over g of s here. So when I go back down to this equation here now, I realize I need to get f of s and g of s separated out in order to solve for those ratios of x of s over f of s and x of s over g of s. So that'll be the next step in my solution. So I separate these out, okay, x of s here, separate this out from that equation there, we can rearrange it. So now we have that x of s is equal to, when I separate out, if we go back one more time here to this equation here, I can put the denominator over this, denominator over this, separate those, end up with this relationship here. X of s is equal to 6f of s over the denominator of 5s squared plus 30s plus 40, minus, now I've separated out to the right hand side here with my g of s function, 20g of s over that same denominator there, 5s squared plus 30s plus 40. And the reason we want to do this is because we want to separate out the f of s and g of s. So that's the next step. Reduce, simplify by pulling out our f of s and our g of s. So I do that there, I pull this out here, end up with now x of s. When I pull out my f of s is 6 over that denominator of 5s squared plus 30s plus 40. There we go, that's separated out. Pull out my g of s on the right hand side of this equation here, minus 20, I pull that out there, over my denominator of 5s squared plus 30s plus 40, times that out there. So now those are pulled out, separated. So, thing to note here, there is more than one input. So the transfer function for a specific input can be obtained by temporarily setting all the other inputs to 0. So this is a little trick along the way for our solution, so we can set our f of s to 0, we can set our g of s to 0, solve for them separately. So let's do that now, where we set our g of s, the right-hand side equal to 0 here. So if we set that equals to 0, this whole term goes to 0 there, and I'm just left with this expression here for x of s, where my x of s is equal to 6 over my denominator here, 5s squared plus 30s plus 40, times my f of s function, now minus 0, because that whole term went to 0. So looking at this now, I can say, okay, let's divide both sides here by my f of s, and that gets me what I'm looking for. Again, back to my setup page, I want my x of s over f of s. So if I divide this over here by both sides now by my f of s, I get this ratio of x of s over f of s equal to 6 divided by the denominator 5s squared plus 30s plus 40. So now we want to repeat that same process, but this time, rather than letting g of s equals to 0, we're going to set f of s equals to 0 here. Plug that into the left-hand side of that equation right there. So this goes to 0. So now our expression for x of s is equal to that 0, from letting f of s equal to 0, equal to negative 20 over our denominator 5s squared plus 30s plus 40 times that g of s. So again, same type of thing that we did on the previous page for our solution. We want to divide both sides by our g of s. And again, now this is to get what they asked us to solve for in the problem, the ratio here of x of s over g of s here. So we do that there. Divide this over, x of s over g of s is equal to 20 divided by the denominator 5s squared plus 30s plus 40. So that's as far as they asked us to go, but I'm going to take this one step further so that we can do some hand solutions, do some MATLAB coding in order to practice how we'd solve this next step further, which again now is to look for the roots of our denominator here. And we can note that the denominator of both transfer functions are going to have the same roots. They have the same denominator there. So let's take a look at that denominator, our 5s squared plus 30s plus 40. So the first thing I'm going to do is, this is a pretty simple one. Let's just solve this by hand solution using the quadratic equation here. So we look at this here, we have our a, our b, and our c. We can say a is equal to 5, b is equal to 30, c is equal to 40. Our general equation for our quadratic equation right here, x is equal to negative b plus or minus the square root of b squared minus 4ac all over our 2a. So then, again, I put my little note to the side of what I'm doing here. I'm going to plug into this equation here with my a, b, and c for my specific equation here from that denominator. So x is equal to negative 30 plus or minus the square root of 30 squared minus 4 times 5 times 40 all over 2 times 5 plug those values in, simplify it down. Negative 30 plus or minus the square root of 900 minus 800, all divided by 2 times 5, or reduced down a little bit more. Negative 30 plus or minus the square root of 100 over 10. Well, the square root of 100 is 10, so we have negative 30 plus or minus 10 over 10. Now, two different solutions to this, two different roots. Answer 1, we do minus. Answer 2, we'll do plus. From this right here, answer 1 is equal to negative 30 minus 10 over 10, or negative 40 over 10, or a root of negative 4. Answer 2, negative 30 plus 10 over 10, or negative 20 over 10, which is equal to negative 2 for our root there. So now we've gone through and shown that we can pretty easily solve for the roots by hand with our quadratic equation. Well, maybe there's different scenarios, different A, B, and C values that they ask us to solve this for, an array of them. This is where it makes sense to start writing out some code for this. Particularly, let's deal with MATLAB for this one. You can do it in Python or even in Excel. We're going to stick with MATLAB for this solution here. So I know it takes a little bit of time to come up with a script file for this, but it does save us some time later because this gives this to us in a generic form here where we could easily, right here, change out our A, B, and C. So I label this, comment this out. This is my quadratic formula. I'm going to clear all my other variables, clear all my command window out here, and now I have a little comment here for the general form. A, x squared plus bx plus c is equal to 0, where my A is given to in our problem is 5, B is given as 30, and C is given as 40. Again, we can easily swap these out. Then I have answers based off of my quadratic equation I've typed out by hand down here for answer 1 and answer 2. Answer 1 is equal to negative b plus. Then we end here, we have the square root of b squared minus 4ac all over 2a, written out in code here. And then we have the minus version of that there. So there's our two roots based off our quadratic equation. I'm going to display answer 1 and answer 2 for this here. So then we can go up top to our script file here, and we can run this. And when we run it, pop down here to our command window, we can see answer 1 is negative 2. Answer 2 is either negative 2 or negative 4. So our answers here are negative 2 and negative 4. So now we can go back over here, and I've kind of wrote out this script file for you, and this is given in our lecture slides as well, and you can see our final answers here of negative 2 and negative 4. And we can go back up and double check that with our hand solution on the previous side, negative 2 and negative 4. So a great double check to check your hand solutions with this MATLAB script as well. And the beautiful thing about this MATLAB script is once it's written once, you can tweak this code for any type of these equations that you need to solve.